Okay, hi everybody. Today we're going to go over the combining transformations handout. This was from the week before March break, but I added a couple things to it. So again, given the generic function, right, y equals a f at k x minus c plus d. Okay, again, the f could be any function. It could be the x squared, the root x, the 1 over x function. Okay, these parameters a, k, c, and d all have the same effect on each of the graphs. So recall that A is a vertical stretch or compression. Okay, if negative, a reflection in the x-axis. Okay, K was a horizontal stretch or compression, okay, by a factor of 1 over k. Remember, what's inside here is always the opposite. So if it's a minus, it goes to the right. If k is a number like 2 or 3, it's a compression by 1 over 2 or 1 over 3. Okay? And again, if negative, a reflection in y-axis. Okay, and now for the C, again, this is a horizontal translation. Okay, fancy word for shift. And D is a vertical translation. Okay, the next part, things to notice, and this is what we talked about before break. Within the function, it must be in the k x minus c must be in factored form. If it's not, you must factor. Okay, so common factored form. Oops. Common factored form within the function. All right. So let's go on to our example here. And we went through this as a class again, but we will I'll just briefly talk about it. So it says describe the transformations below, then sketch, and notice that we just have a generic function, just 3 points, and I called the function f at x. So we have 3 things happening here. We have the negative, we have the 2, and then we have the 1. So again, the negative is a reflection on x-axis. The 2 is a vertical stretch. And we are going up 1. Okay, so the way that we can graph these, rather than like doing each one separately, we can just do it all in one step. So what we do is we take each point on the given function, we call it xy, and what happens is the x values are going to stay the same because there's no shift, x stays the same, and the y values, we're going to multiply them by -2, so -2 times our y values, and then we're going to add 1. Okay, good. So the next one here is first we're going to put it in common factored form. So we're going to factor out a 2 and we get x minus 3. Okay, so now I want you to notice here that there's nothing to the left of the f and nothing after the bracket, which means there's nothing happening to the y coordinates. So you go here to the left, y, after the bracket, y, within x, okay? So this right here is a horizontal compression, right? By, and I'll just write it here, 1 over 2, and we're going to go right 3. So we're going to take each point on the graph above, and we are going to compress the x values. We're going to multiply them by 1/2, which is the same as dividing them by 2, and we're going to add 3. Y values stay the same. Okay, and I'm not going to graph them because we already did in the note. Okay, next one right here, we have a reflection in x-axis. Okay, now notice it's the left of the f, so it's y. Now if we look in here, that's 0.5, right? So it's a number less than 1, so that's going to be an actual stretch. So it's going to be a horizontal stretch by 1 over 0.5, which is equal to 2. Okay, and then we are going to go up 3. Okay, so any point becomes, you multiply the x values by 2, that'll cause a horizontal stretch, and the y values would be negative y plus 3. Okay, and last one right here, we have a vertical compression by half. We have a reflection in y-axis. And we have a horizontal stretch by 1 over 1/2, which again is 2. So any point xy is going to become negative 2x and y over 2. Perfect. Okay, now for these ones right here, again, we have these in the notes, so I'm not going to go through and do this one. I'll just explain each one here. So you're going to have a reflection on the x-axis, a vertical stretch by 2, up 3, right? Because these affect your y's to the left, y and y, and this x and x, right? So you're going to have a compression by 1 over 4, and then we're going to move left 1. Reflection on the x, down 2, reflection on the y, horizontal stretch by 2, right 2. Okay, now this is the new part of the note here. So you can add this into your note. So the difference here is instead of writing like 2f, instead of writing like this, like 2f at x minus 1 plus 3, I actually wrote it as a particular function, which is the square root function, but the effects are still the same. So we have a vertical stretch by 2, we are going up 3, and we are going to the right 1. Okay, this one right here, okay, same thing. Instead of writing it like this, 2f at x minus 4 minus 5, I wrote it like this. So we have a vertical stretch by 2, down 5, and right 4. Okay, now for the domain and range, right, again, stuff that we talked about earlier. Okay, there's two ways you can do it. You can imagine what the graph looks like, okay, or you can actually look at it mathematically. So we know mathematically, we know that x minus 1 must be greater than 0, which means x must be greater than 1. And if we make x equal to 1, we're going to get y is equal to 2 times the square root of 1 minus 1, which is 0 plus 3. So for all other values, y is going to be greater than 3. Okay, if I put a negative out front of the 2, to the left of the 2, then it would be y less than 3. Okay, and for this function right here, again, you cannot divide by 0. So x minus 4 cannot equal 0, which means x cannot equal 4. And y cannot equal negative 5. It's always this last number out here, okay? Always. Okay, and for this one right here, okay, again, this is the function, x squared, so these numbers are to the left and to the right, so it's just all y's. We have a reflection on x-axis, a vertical stretch by 4, up 1. And now this is a parabola, opens down, so parabola, the domain is always x is an element of the real numbers, it's every number. And the y values, y is always going to be less than or equal to 1 because it opens downward and the vertex is at 1. Okay, and the last one here, we have a reflection on x-axis. We have a reflection on y-axis, and we are going up 3. Okay, now this one right here, it's a little trickier. So for our domain, notice that it's negative x, so that means it's going to be x must be less than or equal to 0. Because if I put a negative and then a negative, it becomes positive. And for my range, the largest value y is going to be 3, so y is going to be less than or equal to 3 YER. And we should just tack on the YER. Okay, that's it for today. This is actually the Monday, April 6th recap lesson. Tomorrow's lesson we'll get into sketching these types of functions here rather than just the f of x functions. And then we have our inverse function, and then that'll be it for this unit. And then we will get on to some sort of assessment and a Desmos project. Okay, and I'll keep you posted on what that is going to look like. But for today, I want you to try page 129 to 130. Questions number 1, 2, 7, and 11. And that's it. Take care.